Hello, everyone, and thank you so much for joining us for today's webinar brought to you by CodeFresh Live. Today, we're presenting Making the Business Case for DevOps and CI/CD. My name is Taryn Jones, and I'll be your moderator today, but our presenter is Dan Garfield. He is the Chief Technology Evangelist for CodeFresh, and he's going to show you how to avoid the pitfalls of reactive DevOps in 2020. He'll take a look at several case studies from major companies and provide tools to calculate cost savings and investment for DevOps. We will be taking your questions throughout the session. Just please submit them using the Q&A button on your Zoom toolbar rather than in the chat so we can keep better track of them, and we'll address them at the end of the presentation. This session is being recorded, and a link to the recording will be sent to you by probably by tomorrow. Lastly, please remember to reference codefresh.io/events for upcoming webinars, as we have fresh and informative webinars for you several times a month. So that's it for housekeeping notes. And with that, I will hand it over to Dan. Thanks, Dan.
Thank you, Taryn. So this, I think this will be a fun presentation. You know, I have sort of traded in my terminal and demos for a more business-oriented discussion. I've, in preparing this, and this is something that's been in the works for, honestly, at this point, a few years, where in discussions I'll have with people, we'll go through the tech, and we'll talk about how to build stuff faster, how to deploy faster, how to solve problems, how to do canaries on Kubernetes, all those kinds of things. But I hear constantly, all the time while we're doing that, people are saying, well, I'm having a hard time convincing my business that it's worth investing in DevOps, that it's worth investing in this stuff. And they don't understand why it's so valuable. All they see are costs. And so we wanted to have a discussion around, how do you get everybody on the same page of how they should think about this stuff from a cost perspective? Because engineering is not a cost center. It's an innovation center. It provides the value of your company, right? So that's the number one thing we're gonna work on in this. And I think we can do it with numbers, we can do it with math, and it can be great. As Taryn mentioned, I am the Chief Technology Evangelist for CodeFresh, and I am also a Google developer expert focused entirely on cloud and Kubernetes and you know, how we build and deploy software. I'm also a member of the Forbes Technology Council. And to tell you, kind of frame this discussion, why does CodeFresh, why do I care about this stuff? What we do is we're a CI/CD platform, and we replace tools like Jenkins, if you've ever heard of that. And basically, we handle the cycle between when code is checked in to when it's deployed. And that life cycle, that loop, is the critical loop that we want to put the most attention on speeding up as much as we can, because it means happier engineers and more value, and we're going to get into it. So as Taryn mentioned, please shout your questions into the question box here. I would love for this to be more of a discussion between us than a straight up presentation. It'll keep everybody more interested in any way. And so to start off, we need to remember that engineering and business doesn't always speak the same language. Engineers want to talk about the tech. We want to talk about the architecture and why we think this is better. We want to talk about scalability and innovative solutions and things like that. But the business wants to hear about dollars. It wants to hear about revenue. It wants to hear about costs. It wants to hear about margin, all these kinds of things. So we're going to bring this language into our engineering discussion so that business can actually understand, even if they might not understand what it is that we do, at least they'll understand why it's so valuable to them. So we're going to take that paradigm. There's this great blog post that illustrates this point very well, that it was a guy named Michael Lynch. He quit Google 2 years ago, and he said he quit because he couldn't figure out how to translate his value into something that the organization understood. And this is kind of amazing because Google's, of course, a big tech company, so you'd think that they would understand the tech value very well. But he said, ultimately, quote, "I couldn't prove that anything I did had a positive impact on Google. My bug discoveries caused the overall bug count to increase." What he did when he came in was he found all these services that weren't recording bugs properly. So he fixed that so they would record bugs properly. And then in his performance report, they said, wow, you've been working on this service for a few months and the bugs have gone up, 3, 4, 5x. Seems like you must not be doing a good job. Can you imagine the conversation? So what we need to do is, as engineering organizations, as DevOps people, let's see that we can communicate this a little bit more effectively. Now, one thing that I want to mention in a lot of these numbers is that what we're doing here is making generalizations and calculations that are fairly normal in gross terms. Now, your mileage may vary individually, and if you see any problems with these numbers, I'm very happy to take notes or comments on this, and we can improve them and sharpen them over time. But we basically use the best available data to tell this story, and usually, engineers, sometimes we get a little bit hung up on the details of, well, is this number exactly this or is it exactly that? While business is having a hand waving, napkin math kind of conversation. So one of the things that I've had to learn even in my career is that sometimes I want to present all of the nuance of a number. And I've learned sometimes in business that it's important for people to understand the nuance, but it's really important for them to understand the bottom line. And so that's what we're going to focus on today. So we're going to talk about DevOps. We're going to talk about 4 specific ways that DevOps provides value. We're going to talk about how to calculate the dollars. We're going to give you some tools that can help you do this. We're also going to talk about build versus buy, because this is also a constant discussion that people are going through. Now, within the DevOps world, there's really 2 sides to it. You've got your productivity engineering. These are the people who are focused on making sure that engineers are as productive as possible. They waste as little time as possible when it comes to getting their changes into production or deployed. And then you've got your site reliability engineers, and they're thinking, how do I ensure that our service runs effectively and we don't have downtime? And these are really a push and pull of the same coin. You're going to see that in a second. Productivity engineers, they've got metrics like change lead time. That is, from the moment that I commit a change, how long will it take me to get it into production? And in most organizations, it's days, often weeks. There's a growing minority of companies that are able to do deployments within the same day. And some can do it within the same hour, right? We're going to talk about why that's important. Another element that's important is deployment frequency. How often can we deploy? If you're deploying, or actually there's a great quote that says, if you're bad at something, do it more often. Now, if deployments are painful, do them more often and you will make them less painful, because you have to do them all the time. I will force you into it. And actually there's a lot of wisdom in that we're going to get into. Site reliability engineering is thinking about change failure rates and how long it takes for them to recover from a failure, how much uptimes they have. Now, from a business perspective, productivity engineers, the business just needs to understand, the faster my engineers are, the faster we get value from them. That's what they want to know, right? And we're going to put those into dollars. And for the site reliability engineers, the business understands intuitively, we're going to sell a lot more if the website is up than if it's down. So let's have good reliability, right? So the first area that DevOps can provide value that I want to look at is avoiding downtime. Now, you can find a ton of stories about how expensive downtime is. Amazon went down for 13 minutes and it cost them $2.5 million in lost revenue. That's just 13 minutes. Now, Costco just recently, and I'm sorry if you're from one of these companies, I don't mean to pick on you. It happens to everybody. But Costco went down over Black Friday, that Cyber Monday weekend. They had an outage that cost them about $11 million in lost sales. And I actually experienced that as a consumer. I was actually trying to buy a fridge, and their site wasn't there. And so I went looking at Best Buy, and the price was pretty good. So we actually saw that. I actually experienced how this would work in real time. And if you think about the nature of outages, they're the most likely to happen when you're making the most money because people are using the service the most. So you have to think about the risk from that perspective. Hey, everything runs fine day to day. If we lose some peak times, that's okay. It's not okay because that's actually where most of the revenue is. Southwest Airlines had a really crazy outage a few years ago that cost them about $82 million. So when we think about downtime and how expensive it is, it's something that we do need to focus on and make sure people understand. Now, in order for a company to make money, you really need three legs of a stool working. You need your sales team working, you need your marketing team working, they're bringing in the deals, they're closing the deals, whatever. And then you need your engineering working. And if engineering falls over, the revenue falls over. If sales falls over, the revenue falls over. As marketing falls over, the stool falls over. So you need all of them, which means that when it comes time to calculate the value of uptime, you should actually go off of your total revenue numbers. Because if the engineering falls down, sales can't function. Sales falls down, it doesn't matter how good our engineering is, people can't buy, right? So if you had a company, and the example that we looked at was Amazon, if you've got $107 billion in revenue, you divide that by 365 days, divided by 24 hours, divided by 60 minutes, gives you $200,000 per minute. Now, that is a very easy, generalized way to look at the cost of downtime that is fairly accurate. Now, in the case of Costco that we talked about a second ago, and again, I don't want to pick on Costco. They're a great company. I got my executive membership, folks. I'm a big fan. I use it all the time. In the case of Costco, the cost was much higher than the revenue per minute because it was during peak times. Now, during that weekend, I think they probably usually do around 4 or 5x the business, which means we would take this per minute total and 4 or 5x it. So the 107 billion, I think is, yes, this is actually Amazon's, this is a stat from Amazon when they had an outage a few years ago. So during something like a Black Friday event or something like that, it's going to be 4 or 5x this. So it's more like $1 million a minute. So you can do this with your organization. Just take the revenue, divide it over time, and you have a pretty good estimation of what you're losing for every one of those minutes. Now, it's possible that some people will come back and buy later. That can happen. But it's also possible that people write off your service because it was unreliable. So any argument about how you might capture some of that revenue still is countered by the arguments of why you wouldn't have any repeat business after this. So that's downtimes. Now, when it comes to the standard that people talk about, they're saying, I want 5 nines of uptime. 5 nines, to be clear, means you only get 5 minutes of downtime per year. This is incredibly difficult standard for people to meet, and you have to be thinking about your uptime like the pit drivers at the 24 in Le Mans. Like this is an all out. You have to be engineering really, really well. Anybody who gets 5 nines of uptime in a year. Now if you have 5 nines of uptime in a month, that's a different story. But if you have 5 nines of uptime in a year, you deserve a huge gold star. And for the business, you need to make them understand that it is like running a constant race, and it's that difficult. So that's what you want to communicate to them. Now, from a cost perspective, now we just looked at Amazon, right? If they have 5 nines of uptime, and we expect that those failures are going to happen during peak times, we know that they're losing about $5 million a year off of lost revenue. from having those purchases go through. Between 2 to 5 million, right? So when you're looking at what you need to invest to improve the uptime, you can always take that number of what you've done, what the revenue is, and then put it against the investment to say what you need to do. So if you're at this 99.9% of the time, you're losing 8 hours. Depending on your revenue, this could be a much, much larger chunk. So if you say, look, if we invest $10 million, I think we can get from 8 hours of downtime per year to at least less than 10 minutes of downtime per year, and it's going to save us this much money. Then your business case is made, and it's very clear why people should invest in it. So in order to make your uptime work, you need everything working perfectly in concert. Your continuous integration process needs to be on point. Your integration testing needs to be on point, so that you don't have regressions, right? Your continuous delivery needs to be really sharp, and you have to have infrastructure that's designed for this, right? Now, from a continuous delivery standpoint, we've got a great webinar, we've got several actually, about doing canary releases, which is where you can do a release, but you only expose a small portion of your users to that new version. So if there's a regression, the blast radius is contained, and you do an automatic rollback to put things back the way they were without having a big outage and a big loss in productivity. So that's to do a canary release. That means your continuous delivery, your CD platform needs to be on point, your testing needs to be on point. All of those things have to work together. And Taryn just put it into the chat, the link to that webinar if you want to check it out. Now, this really means that there is a tug of war going on between delivering code faster and having good uptime. And we can deliver changes directly into production with no testing, but our uptime is going to be garbage. We're going to be out of business. So we have to have excellent ways of working that and enforcing the uptime. So the SREs are pushing and saying, hey, we need better quality software. We need better testing, better ways to do our releases, battle-hardened infrastructure. And the code delivery people are saying, we need to go faster, we need to go faster. And they're pushing against each other. And this is the world of DevOps. That's what's sitting in between. So it's your job to figure out how to balance those things out, to go for the uptime, and then to unleash the code delivery to happen as fast as possible. And we're going to talk about exactly why that is. Now, this is the difference between daily releases and quarter releases, right? So on a daily release schedule, and I'd like you to get down to, I would encourage people to go for doing releases on demand or potentially hourly. The changes that you deliver are smaller, right? They're atomic commits, and those atomic commits have less chance to fail, right? Because they're smaller changes. Now, if you're deploying quarterly, that means you have a huge release that you're putting out all at once. The odds that something goes wrong are much, much larger with just by nature of how much code you've delivered versus with these small atomic releases. So the business logic to understand is that deploying more often actually reduces risk. And that's critical. So you want to build the discipline to be able to deploy more often because it's going to reduce risk. You're going to have better uptime. Now, this actually goes into the second value, which is delivering faster. So the first one is improving uptime. The second one is delivering faster. I wrote a maxim and I stuck it in here as a quote from this presentation. Unwritten code has the same value as undelivered code. If you do not deliver the code, it is just as worthless as code that's not written. And this is an axiom that you can live by. So what you want to understand is that every software change delivers value. Every single one. If it were not the case, you would not have the engineers working on those changes. Why do the software engineers write anything? Because it's meant to provide value to the company. Now, some commits are worth more than others, right? And you can see over here, I've got these number of commits, and one of them is worth 20K in business value. One of them is worth $10 million in business value. That's a real example, by the way. I worked was working with an engineering manager a while ago, and they were getting ready to release this change that was going to make their company an extra $10 million a year. They had it all dialed in and knew exactly how much it cost. Now, if that change takes an extra week into production, you just lost a week worth of value, a week out of that $10 million additional revenue, right? So you just take that $10 million divided by 52, and now you've got the number of what you just lost because it was delayed a week, right? Now, it's less about that one change. It's more about all of the changes in aggregate. If we can deliver code faster, it will provide value faster. And for the business logic on that, I always like the example of supply chains. So if you ask anybody, what's Apple's greatest innovation? What have they done better than anybody? And people will say, oh, the iPod was amazing. The iPhone, of course, changed the world. The App Store, a whole new paradigm for consuming software, made a big deal. Monobody aluminum notebooks, as Johnny Ive always says, those are fantastic. What Apple does better than anybody is supply chain. What's Tim Cook at? Tim Cook is a supply chain expert. He's not a software expert. They have the best supply chain in the world. If you order something off of Apple, within 30 seconds, their entire global supply chain has been updated. Work schedules in factories have been updated to reflect your purchase within 30 seconds. And as a result, Apple carries, I think, like 7 days of inventory. So if you go to an Apple store, you'll notice that lots of times they need to order stuff in. It's because of their supply chain, the way it works. And that means that a competitor of theirs who has to carry 3 or 4 months of inventory, they've got tens of millions of dollars locked up in a warehouse and sitting on a shelf that they need to move and sell before they can get those dollars to invest into the company. Apple only carries that loss for 7 days, right? So they get the value much faster. Now we did a case study with Steelcase that I would encourage you to check out, where their code delivery cycle went from 3 days to 3 hours. So we basically cut 3 days off of how long it takes for them to deliver software. So how much is that worth? Well, Steelcase last year had a revenue of $3.4 billion. And I actually wanted to estimate, mistake here, that they had roughly $300 million. Just gonna fix that. They had roughly $300 million. This is our estimate, by the way, that they had roughly $300 million in value from their new software. And this means that by delivering software 3 days faster, assuming that all the software was delivered with CodeFresh, which it wasn't totally standardized when we did this case study, though it was going that direction, that means that they're going to deliver about an extra $2.5 million in value to the business. So cutting 3 days off for them was massive. Just delivering that software faster meant a couple $1 million more onto the bottom line. So now we've actually shown, and there's a calculation in here you can use. So this is the calculation that you can use. It's basically what the business value is that you pushed next year times the time saved divided by the time period. If you don't know how much value you delivered, for a very rough estimate, you can take an engineering salary, all your engineering headcount costs, and multiply them by 8. And that would be somewhat industry standard. The range of business value delivered by engineers varies widely at different companies. So it's a bit of a spitball kind of multiplication to do, but it does allow you to think that and get some idea if you don't know what the business value is. Now, if all the code you're shipping is junk, then the business value is significantly less, right? If you're shipping gold every day and your company's making great money, then obviously it's going to be higher. So so you can estimate that and then actually figure out what the cost savings will be by lowering your lead time to change. So this is that productivity engineering side of the DevOps equation. I mentioned that this code delivery loop earlier, this is the one that CodeFresh focuses on and where our platform is designed for. This is the critical loop that you want to shorten as much as possible. And, we have customers that do this in minutes, people that do it in hours. We have some that do it in days, just because of it, whatever internal process that they're sticking onto. We actually had a customer who moved immediate to continuous delivery on CodeFresh, and they said, actually, we realized that this is a little bit too fast for us because we just need to get our organization to understand this. So they actually put in some artificial ways to slow it down so that they could get their organization to catch up, because that stuff needs to come together, right? Of course, still huge cost savings on it. Now, this lead time to change is the time from the average days it takes from the first commit to deploy. And this is the critical loop that you want to speed up as much as possible. This goes into the third value that DevOps can help with, which is just saving engineering time. And there are a lot of ways to save engineers time so that they spend more of their time focused on delivering new code, new business value, rather than chasing around bugs or getting things ready for shipping, right? If you can cut 5 minutes off of a build time, let's say you're in an organization with 1,000 engineers, and they each do about 5 builds a day, and they're making an average of $1.25 a minute, which is pretty standard engineering salary. That means that every year, just by building 5 minutes faster, we're going to save $8 million of engineering time. Now, with a metric like this, there's some debate about the effectiveness of these numbers, right? Because if I cut 5 minutes off of a task, that may or may not realize value immediately, right? But when you spread it out over an organization, you spread it out over thousands of moments when we saved 5 minutes. There are tens of thousands of moments where we saved 5 minutes. That value does start to translate. And it's not just in their time dollars either. So if anything, we're underestimating here, because if you look at the effect of this on companies over time, it is more exponential in nature. It's like compound interest. It's a compound effect. And even just realizing that engineers who love the tools that they're using, they're way more likely to want to stick around in your organization than if they have to go through a crappy process every time that they deliver software. So even just there's all these additional savings that are sitting out there. But as a baseline, we can just take engineering time, divide it by the time saved, and we know exactly, we have a very good estimate or a very good idea of how much money we're saving on our engineers. Microsoft recently released something similar to this. They've got, they've of course got tens of thousands of engineers. And so they were releasing a stat that was something like, if we can save 30 seconds on our build time, we save $50 million a year as a company, something like that. So very similar kind of approach. So this is pretty standard. Now I'm talking about just 5 minutes here. In fact, a lot of build systems can shave a lot more time off their builds. This is a quote from Ethan. He works at a company called Hover. They're a CodeFresh customer, and they gave a talk at KubeCon where they talked about how they deliver software. And they mentioned that when they switched to CodeFresh, their build times went from 2.5 hours to under 12 minutes. Now, I'd love to do a sidebar and explain why that is, but that's not the purpose of this webinar. So I would strongly encourage you to check out our container-based pipelines webinar that we did. And we also have some blog posts around this. I think Taryn will probably throw it in the chat because it'll actually explain some of the reasons that this is. So if we went from 2.5 hours to 12 minutes, if we saved $8 million off of 5 minutes, Imagine how much we're going to save if we knock 2 hours and 18 minutes off of our average build time. It's going to be huge, right? Much more effective. So here's the equation: cost of engineering per minute times builds per day times 251 working days a year. That's a standard US calendar. Your mileage may vary if you're based in Europe. You're going to subtract, 100 days from that, but I'm just kidding. Lived in Europe for a while, and I noticed that people often just disappear for a month in the summer. I don't know. I think they might have it figured out. At any rate, you multiply by the number of working days in a year times the minutes saved times the number of engineers, and very easy equation to plug in and get the numbers on. All right. You can also optionally include overhead cost, because when we talk about salaries, every employee actually has overhead above that. That's like the cost to administer having that employee, the cost to like give them health insurance on top of their normal compensation, whatever all those things are. And usually it's 10 to 30% over whatever their salary is. And you can actually get that number from HR if you want to build that into your calculation. All right, number 4. So number 1 was avoiding downtime. Number 2 was delivering faster. Number 3 was saving engineers time. Number 4 is reducing infrastructure overhead. This is the time that we spend managing infrastructure and the cost of that infrastructure. Now, this is where I make my pitch that you should be seriously engaged on what we call the cloud native tool set. So Kubernetes, Docker, those kinds of things. This is not a CodeFresh pitch, a pitch for technology. Sorry. I just watched somebody drop off, and I was like, oh no, maybe they left because they thought I was going to do a product pitch. No, this is a pitch for open source technology. And this is something that happens when people move to things like Kubernetes, is they lower the cost of running their infrastructure, not only from an overhead of just their time managing it, but also on idle time. So right now, about 30% of infrastructure budgets are spent on idle machines. And so this is why a lot of people said, well, maybe we'll all go serverless, because then we never have to pay for an idle machine. Though serverless is actually usually prohibitively expensive, the way it's priced by the cloud vendors, because they know this. But what you can actually do with something like Kubernetes is you can have auto scaling, where you bring in nodes as you need them on demand, and you shut them down automatically when they need to go away. And you can also introduce the idea of spot instances because of this. So if you were Amazon has spot instances, Google has preemptible nodes. I forget what the name is of that technology on Azure. But this, basically what it is, are machines that can be lost at any moment. And because the cloud provider can put you onto, can take over the node at any moment, they will sell it for pennies on the dollar. Now, in order to take advantage of that, you need to have some great infrastructure, some great architecture. Kubernetes makes it way easier to do, because it does have the idea of adding and getting rid of nodes and having portable workloads that can move between nodes at will. But that can actually reduce cloud costs 90%, which is pretty wild. And of course, it has failover. And that's not an exaggeration. You can read the link on here. 90% costs cut by using something like spot instances. Auto scaling, I mentioned a second ago. And the other thing with microservices is that it allows for tighter packing. So when you're doing VM-based architectures, VMs are heavy. Every VM needs to carry around a whole kernel and subsystem with it. And that means that everything basically has a gig built into it that you have to move around and pay for and pay to operate and pay CPU cycles on. When you move to a container, and I've built Go containers that are 2 megs. Boy, I can pack a lot of Go containers into a node with Kubernetes, because it's doing it for me automatically. So you can actually pack your services that you need much, much tighter. You end up with way less overhead. So this is really a push to moving to cloud native architectures, getting Kubernetes, those kinds of things. And This is the kind of language that that businesses should be able to understand. So this goes into the next discussion, which is build versus buy. And this is something that I encounter fairly regularly. We did a case study with a customer where they had hand rolled and built their own deployment tools, and then they were marrying that into their CI tool. And they basically had 2 engineers maintaining it, and they needed to invest a lot more work into adding support for Kubernetes. And in this case, it's a fairly sizable company. They were looking at a $47,000 CodeFresh license for the year. In order to just build the software, they were going to spend about $70,000 on engineering time, but the annual cost to maintain that software was over $200,000. So that meant that just in the first year, they would save almost $250,000 by buying versus building. Now, the variables here are pretty critical. If you understand, and I would actually encourage you, there's a link here that's baremetrics.com/build versus buy. You can plug in your metrics and it will actually spit out, it will walk you through creating this calculation. So you can actually do this with whatever tool it is that you're considering building versus buying. And in most cases, it's cheaper to buy than to build. Now, the only time you don't want to do that is if you're building something that's core to your business, that is a differentiator, that's IP that you have. There are a few exceptions. As a general rule of thumb, think about it this way. Am I building something that we want to sell? If we don't want to sell it, it's probably better to take a tool off the shelf. Now, Amazon famously built AWS because they architected in such a way that they could actually turn around and then sell AWS services. And of course, this was a boon to Amazon revenue. So if you think that that's the path you could go, hey, we can develop this thing and eventually we could actually turn around and sell it to our customers, then that's a very, very smart move. But if I can't tell you how many people have tried to rebuild Salesforce, and it is always a disaster. We actually had an experience. I won't say who the customer is. They're one of the largest gaming companies in the world, but they decided to build their own CI/CD tooling, and they came back to us a year later and they said, we really hate our CI/CD tooling. We're ready to buy CodeFresh. So it's something that you should definitely think about, and this will give you the tools to actually make that calculation, and then just make it off of the dollars. Now you know. So in summary, as engineers, sometimes we're a little bit afraid to put costs to paper, and we want everything to be exactly precise. This is what makes us good engineers, but it's what also makes us sometimes bad at financial things. Don't be afraid to put costs to paper. Get an estimate on there, get it down, at least get the back of napkin math going, because then you can have that number in your pocket. And then anytime someone complains that you want to spend a few extra bucks on the cloud, you can say, we're going to save $6 million a year just by avoiding the downtime. So unless you want to have a conversation about where else we're going to get $6 million, conversation's set. DevOps really is, and this is point number 2, DevOps really is one of the most valuable things that a company can invest in, because every company now is a tech company. We have a customer, Wawa. Wawa, for the East Coast people in this room are like, oh yeah, I know Wawa. For the West Coast people or the European people, it's a corner store. It's like 7-Eleven. It's like a grocery store, okay? They have a huge engineering organization. They're using CodeFresh to build and test and deploy their services. They are a tech company. If their engineering team performs well, their business is going to perform well. It's almost easier to list companies that aren't tech companies than to find one than to list all the ones that are tech companies. There's so many, pretty much every company now. So software engineers are one of the most expensive resources you have, and your services that you run are the most valuable services that you have. So if you can save their time, you can increase your uptime. That makes DevOps one of the most important places to invest in any company. Third point, speak the language of business, use the dollars, use the cents, because once you put a number on it, now you can have a discussion around it. Hey, this is going to save us $6 million. It's going to cost us $500,000. why are we even having this discussion? This is dead simple math. Let's just make the investment and move on. Use the equations that we've shared. All these slides have equations. You're going to get the slides in the deck. I would like to hear from you. If you would like us to provide a online calculator for all of these things rather than just sending you the equation, let us know. That's something that maybe we'll build after this. And finally, give us feedback. I would love to have your feedback. I would encourage you to check out our upcoming events, codefresh.io/events. Lots of events coming up, lots of webinars, lots of content coming out. Lots of related resources to this. CI/CD pipelines for microservices, I highly recommend. Multi-cloud Canary with failover is very cool. Talks about Canary releases across multiple clouds, which is really interesting. And then we have this very fun talk that is, it's kind of clickbaity. Using multi-stage Docker, Go, Java, and Bazel to destroy long build times. That's a pretty good one. So we'll open it up to questions as we come to the end here, and happy to have a little discussion. The first question here is from Anis, who says, any recommendations to tackle the elephant in the room? That is DevOps in a mainframe software factory where code and folks are ancient and resistant to change. Whew. Mainframe software factory. Oh boy, that takes me back. Okay, well, truthfully, they are not going to see it until they see it. So it's very unlikely, if they're not willing to make change and adapt, they're like, hey man, we're dinosaurs, we love it. No meteors coming, we're big, we're large, we're in charge. I got tiny hands and that's fine. If that's the world they're living in, you may not be able to convince them. And so your best bet might actually be to bring in a little bit of new blood and have them focus on a greenfield project. And once people see how that project operates, they're going to start asking questions. The other thing is you can drag them to like conferences to listen to talks. That's a little bit more, that's maybe quicker accessible. But I'll tell you a story about this. I was at a company years ago where we had a, they weren't doing mainframes, but they were sort of dinosaur in the way they developed software. And they were working on building this platform for, about a year and a half, had been invested in this platform. Still hadn't launched anything, building everything up. And we had this skunkworks team that was, they weren't cloud native because this is too many years ago, but they were like hip, software developers. And we said, this project, we spent about a year and a half on it. Take a look at the requirements. What do you think? They caught up with the dinosaur team in a week. They shipped more in a week than the dinosaur team shipped in a year and a half. So that kind of change, that happened. And as soon as that was put onto the table, boy, there was a big shakeup, and we really changed the way we built software at that company. Thankfully, I wasn't on the dinosaur team. Satya asks, do you have any case study on the savings done by moving to Kubernetes, CI/CD, DevOps, microservices in dollar numbers from traditional services? That's a great question. So I don't have a case study that is as comprehensive as what you've described. In this webinar, though, we did look at several case studies that were people saving money by buying instead of building, people saving money by delivering software faster, and people saving money by cutting time off of their build times. And I shared all real examples with you. So it's not brought into a single case study that just says, hey, look, by adopting all this stuff, we get everything. But this presentation should serve as the basis of a case study for you to convince other people. So hopefully that helps. And keep your eyes open. We've got more case studies coming, and hopefully we'll have one soon with a big Fortune 100 company that basically would encapsulate all this stuff. Renee asks, hey, I just joined, didn't care about your presentation. No, I'm just teasing Renee. Any chance you'll be sharing the recording? Absolutely, we will send it out to you. Thank you for joining, even though it was late. We'll send you the recording and the slides afterwards. So in the meantime, while we're discussing this, Taryn's going to throw up a poll here. Really appreciate your feedback. Helps us understand and optimize these things. And I would say, once you start putting, pencil to paper and actually plugging numbers in, the business case for DevOps becomes so clear. And it's very easy to argue. Take this presentation, share it with your team. Say, hey, look at the kinds of numbers, look at the kind of cost savings that we can have. Plug the numbers in yourself, run the equations for your own company, and you'll have a very good reason to expect people to go along with you. And I wish you the best of luck in the dinosaur mainframe software factory. A lot of people resistant to change. All it takes is one shakeup, right? One shakeup can make a big difference. And a story that I always think about with this is from back when the first spreadsheet applications came out. This is back, it was Lotus 123 before it was Excel. And Lotus 123 came out, and every accounting firm charged people based on how long it took for them to put together spreadsheets. And when I say spreadsheets, I mean people sat down with these giant sheets, huge sheets of paper. They would put on big drafting tables, and they would literally draw columns and cells and fill in these spreadsheets. And so if a company wanted to understand the projections, these accounting firms would spend hundreds of hours building these spreadsheets. And every time they wanted to change something, it would take another 100 hours to rebuild. And the reaction from the accounting firms, there were two different reactions. The first group said, if we adopt Lotus 123, we will have nothing to charge our customers on because it will take us so little time that we'll go out of business. The second group said, imagine how many more customers we can handle with this technology. Now, I don't want to spoil the movie, but group number two, they all doubled their business. Group number one, they all took their business to zero. Those firms did not survive. So there's so many parallels with this, where people that are resistant to change are the ones that take it on the chin the hardest. You're either adapting or you're dying. You're like a shark, you're swimming. And if a shark stops swimming, it just sinks and dies. So you always got to be swimming. So anyway, hope that helps. I really appreciate you coming. Really appreciate the feedback. Please follow me on Twitter. I'm @todaywasawesome. Follow CodeFresh @CodeFresh. We share software insights like this, as well as tips and tricks and things like that. And we'll see you next time on CodeFresh Live. Thanks for making it.